I'm Maya Israel. I'm from the College of Education, and I'm here actually representing a team of researchers across the colleges of education, engineering, and political science. And actually what we're going to start with is a problem, and that problem is that there is a range of learners who are not going into the STEM fields for a couple of reasons. One, they have a very naive conceptions of what engineers are, what scientists are, let alone understand the different engineering fields and scientific fields. And so those naive conceptions result in them not choosing those fields. The second is that often content is presented to them in ways that is inaccessible. And so what are we going to do about that problem? One piece of that we're tackling is to create gamified virtual learning environments. And in these, students can engage in problem solving around authentic context and not just learn the content of science and engineering, but do it within the context of how do scientists think, how do engineers think. And so our hypothesis within this is if we can build features for kids who struggle, if we can increase their engagement, motivation, and access to content, that system will inherently be better for all people. So that universal design is going to be in there. And so the research goals that we have around that is which components of that have the biggest bang for their buck. So if we're going to lower the floor and increase the ceiling, what's going to do that best? What's going to engage kids more, and what's going to provide them with the most access point? And so that traditionally, those students who traditionally avoid the STEM disciplines will have those access points. So in terms of development, we have two main areas. One is really focused on access, and within that we're thinking about very seriously, how do we take data, how do we take concepts and apply visualization to that? So things such as heat transfer that can be really complex can be presented to students in a way that is more accessible. We're also thinking about scaffolding the process so that students who have very little expertise can still engage in content, and as they increase in sophistication in terms of their understanding, they will also be able to grow with the system. On top of that, what we're wanting to do is leverage what we have here at the university, which is incredible wealth of data and resources. So using quantitatively accurate data, and in this case we're looking at climate action and zeros, which is a zero net energy home content within these systems. So this is one example. It's a screen capture from Zeros, which is the Zero Energy Residence Optimization software, which is developed by Newell, and it allows users to be able to look at different variables in home design, such as wall thickness and insulation and so forth, and then see how that affects the sustainability of their home. And so that's one example, but the way that the data is presented isn't necessarily in a way that a lot of students will be able to find helpful. But it's a real simulation system, so we can use that as the backbone. Here's an example of climate action, which looks at climate change, which Cliff Singer, who's in the back there, has developed. So looking at global warming and cost to society, so not just at carbon emission, but what it does to GDP for developing and developed countries. So what we start with is we look at what kids know and what they want in terms of these systems. So these are some paper prototypes that children have developed. It allows us to see what they expect these systems to look like, but at the same time it allows us to see what their misconceptions related to content is. And then what we do is we develop our own wireframing in terms of that. Here's an example of EcoBuilder, which is based on the Zeros simulation data, and it shows that there are multiple pathways to get into content, from a level up system to a sandbox where you can look at multiple variables within like one environment, and a co-op, which allows people to work together but look at multiple stakeholder perspectives to try to solve a fairly sophisticated problem together. Here's another wireframe that shows some of the access points that you can get into this. But essentially what we want to do is we want to use Zeros and we want to use climate action as the core of our first prototypes, but ultimately have a blueprint for designing these virtual games across content. So we can look at bioengineering, you can look at ecology and sustainable cities. So within this community of practice of students and faculty that are here and we're hoping to collaborate with, create the system across content. Thank you.